In this video, we'll be learning how to factor polynomials completely by mixing multiple factoring strategies together. So far we really talked about 4 factoring strategies. We have the greatest common factor, which is where we're always going to start. We have the factoring a trinomial using those a, b, and c values. And then we have these 2 final strategies here called perfect square trinomials and difference of squares that involve those perfect square shortcuts. So we're going to be looking at how we can use all 4 of these and use them in different combinations to factor a polynomial completely. So you're each going to receive a copy of this factoring polynomials flowchart. And a couple of things to keep in mind with this flowchart as you use it. There are some general hints across the top. So a couple of things to remember is that before you factor a polynomial, you always want to rewrite it into standard form, which means it's going to decrease. Those degrees, those exponents are going to decrease in order as you go. The second thing is that you always want to factor out the greatest common factor first, which you're going to see here is the first step in your flowchart anyway, so that's always our first step. Secondly, if something can't be factored, it's called prime. We don't see a lot of those or haven't seen a lot of those yet, but those do exist. And then your answers can all be checked by multiplying them back to standard form. So when we walk through this factoring flowchart, the first thing we're going to do is we're always going to factor out the greatest common factor. You're going to see how doing this actually makes the factoring process a lot easier because oftentimes it makes that trinomial easier to factor if we pull that greatest common factor out in front. So if there's a greatest common factor, that's your first step. And then you have to ask yourself how many terms are left. And typically it's you've factored something out in front and then there's items left inside the parentheses here. And this is what we're focused on. How many terms are left in the parentheses that we can look into factoring further? If there are 2 terms there, we're going to look to see if those 2 numbers are perfect squares, because essentially what we're looking for is, do we have a difference of squares? And if we do, then we're going to rewrite it using a difference of squares. And if we don't, we're just going to leave it and we'll only have one strategy used. So that's the first pathway of the way things could go with this one. Then from here, the other question we're going to ask ourselves is, if there's not 2 terms left, are there 3 terms left? And so we're going to start looking at those 3 terms and we're going to ask ourselves the same question, are the values for A and C perfect squares? If the answer to that is yes, then you need to look and see if you have one of those perfect square trinomials. That's what we're going to look for first, and we're going to use one of those perfect square strategies to factor that part left in parentheses here. If A and C are not both perfect squares, then we're going to head down this pathway. And we're then going to look at factoring the trinomial using the A, B, and C values. So if A is equal to 1, you know that we have a shortcut that we can use. If A is not equal to 1, the process is a little bit longer. But those are kind of the questions you want to be thinking about as you factor polynomials completely, starting with your greatest common factor and then looking at how many terms you have to decide which strategy then might be the most appropriate moving forward. So let's take a look at this first example here. So we're going to work on solving this equation and using factoring in order to do so. So remember, if we're using our flow chart, our first step is always going to be looking for a greatest common factor. And we can see how this is going to be helpful here because this has some really large numbers. 20, 140, and 245 are really large to factor with. And what I notice is they either end in a 0 or a 5, which tells me that these are all divisible by at least 5. So I'm going to start there because I know that's a factor of 20 that I could factor out. I also notice that they have at least one x in common, so I'm going to factor out that 5x as a whole. And if I do that, 20 divided by 5 is 4. The x cubed over x to the first, we subtract those and get x squared. Then negative 140 divided by 5 is 28. X squared over x to the first, we're left with just x to the first power because 2 minus 1 is 1. And then 245 divided by 5 is a positive 49, and the x's cancel. So we can see here how we have factored out a greatest common factor. Now, this is where we're going to potentially use a second strategy. So we want to look right here at this part left in blue inside the parentheses. And what we're looking for is, do we have another strategy we can use? And if I look at the number of terms, I notice that there are 3 items or 3 terms on the inside of that parenthesis. And so essentially what I'm looking to see is this a perfect square strategy where I can use the perfect square trinomial? Or am I going to factor by using the ABC values? And when I look here, I notice that the square root of 4x squared is 2x, and the square root of 49 is 7. So this is definitely a possible candidate for the perfect square trinomials. And so the way to check is to look at that middle term and take 2x times 7, which is 14x, multiply it by 2, and that equals 28x. So what this tells me is that I can use this 2x and this 7 to factor this part a little bit further. And so I have 2x in the front to be multiplied, 7 in the back to be multiplied, and then in order to get a negative middle term, I need to have 2 negatives. So now here I have factored this part in blue further by using the perfect square trinomials pattern that we've seen. Now the last thing we have to do is bring down this 5x. And here we have our final factored form. So our last step here, because this is an equation we're trying to solve, is we're going to set each little component, something times something times something equals 0. We're going to set each little component equal to 0 because of the zero product property, and solve for x. So here we divide by 5. Our first answer is x equals 0. Here we add 7, so we have 2x is equal to 7. Divide by 2, we get 7 over 2. Then we do the same thing here. We divide by 2. We also get 7 over 2. And because that's a repeated answer, we just need to list out the 2. So now let's take a look at this second problem. When I look at this second one here, what I notice is that I don't have the equal to 0 part that I need in order to use the zero product property. So we're going to start by subtracting 130x from each side. Now from here, I need to be careful how I write this. I need to make sure that this goes in descending order. So my x squared comes first, followed by my x term, followed by my constant at the end. So now I have the 0 part of my zero product property. So my next step is to set up a product. And so this is where factoring is going to come in. Now, the first thing I need to do is I need to take a look at this expression as a whole, and I need to decide if it has a greatest common factor. When I look at this, I notice that they all end in 0. So I'm actually going to factor out a 10 because I think their biggest common factor is 10. Then I look at their variables, and while 50 and 130 have an x, 60 does not. And so I'm just going to factor a 10 out in front. So that leaves me with 50 divided by 10, which is 5, and then the x squared is still there. Negative 130 divided by 10, which is a negative 13, and the x is still there. And then 60 divided by 10, which is 6. So here we can see that we have factored out a greatest common factor, and now we're going to focus on this part right here to see if it factors a little bit further. So because there are, again, 3 terms, I need to think through what strategy might be the most appropriate. And when I look at 5 and 6, those aren't perfect squares, so I'm not able to use the perfect square trinomial shortcut, but I can use my ABC values. So I have A is equal to 5, B is equal to negative 13, and C is equal to 6. So then I'm going to multiply A times C, which is 5 times 6, which is 30. We're going to add to B, which is negative 13. And so I need to think of 2 numbers that multiply to 30, but add to negative 13, which would be negative 3, and negative 10. So I'm going to come over here to my part underlined in green, and I'm going to factor that. So I have 5x squared minus 3 times x minus 10 times x plus 6. So I'm going to find the greatest common factor here, which between 5 and 3 is just 1. So we're going to factor out a 1x there. And then we have 1x in common, so that's where the x part of that comes from. So if I factor out a 1x here, I end up with 5x minus 3, because 5 divided by 5 is 1. Sorry, 5 divided by 1 is 5. And then the x, you subtract the exponents, 2 minus 1 is 1. And then negative 3 over 1 is a negative 3, and the x's cancel. So now my goal is to make the parenthesis part match this piece here. So as I look at these two numbers, I realize I need to factor out a negative 2 in order to end up with negative 10 over negative 2 is a positive 5 times x, and then 6 divided by negative 2 is a negative 3. So notice that my parenthesis parts match, so I can group together the 1x and the negative 2. And then those matching parenthesis parts become the others. So we have 5x minus 3. And then our last step here is we're going to bring this 10 down, and that is our fully factored form. Now, because we have something times something equals 0, we have the zero product property, so we can set 10 equal to 0. We can set x minus 2 equal to 0, and we can set 5x minus 3 equal to 0. And then we can find all the values for x that make this equation true. So if we start here, we'll notice that 10 equals 0, there's no x value there, so this isn't going to be helpful at all. Here, we're going to add 2 to each side, so we have x is equal to 2 as a possibility. And then here, we add 3. We have 5x is equal to 3, divide that by 5. And our other option is 3/5.